this video on writing and solving equations. By the end of this video, you should be able to translate a verbal equation into an algebraic equation and solve them. So this builds off of what we've been learning. If you have it handy, you may wish to take a look at these notes that we took previously just for some of the words to help you with what the verbal phrases are stating to us. So we're going to write some equations and then we're going to solve them. So I just used the words equation and solve, and so we really haven't been doing that yet. And so I wanted to remind you that an equation is formed when an equal sign is placed between two expressions, creating a left and a right side. So previously we've only been translating our expressions, but now we're going to make it an equation. The important keywords that show up that indicate that we are discussing an equation are these are the ones we see the most. So the words equals, is, costs, and weighs means we're talking about an equation, so we want to put an equal sign. Let's look at some examples and see what I mean. So we have the product of 16 and x is equal to, sometimes I say equal to, is equal to, that means we're going to have an equal sign to 32. So the product of 16 and x, as we recall, product means multiply. So we're saying 16 times x is equal to 32. Okay, we wrote an equation. Now to solve the equation, your goal when solving is you need to get x alone. And so we have to use opposites to move things away from the variable in order to isolate it. So in this case, we have 16 times x. So the opposite of multiplication is division. So instead of multiplying by 16, we're going to divide both sides by 16. Because an equation, to remain equal, you need to do the same thing to both sides. 16 divided by 16 cancels to 1, leaving just the x on the left, equals 32 divided by 16 is equal to 2. Okay, let's try it again. So in example number 2, the difference of x and 16 is 32. That's your equal sign right there. The difference, that is subtraction. Now difference is not a turnaround phrase. Remember when we talked about those previously. So we're going to write this in the order that it's written. We have x and 16 with a minus. So we say x minus 16 is 32. So what we said over here is when you have a variable that you're trying to isolate, you need to move the other terms away from it. So I need to move the 16 away from the x, and I'm going to use the opposite operation to do so. So this is minus 16, so I'm going to add 16 to both sides of the equation because that's what keeps it equal. If we add 16 to one side, if we want it to remain equal, we have to add 16 to the other side. Negative 16 plus 16 cancels out to 0, and that leaves just x on the left equals 32 plus 16 is 48. So that value would have to be a 48 to make that equation true. All right, let's try some more. Okay. Example number 3, the quotient of a number and 4 is 7. So is our equals. Quotient means divide of a number. They don't say what the number is. We can use whatever variable. We've been using x. I'll just keep using x. It could have been n, p, q. It doesn't matter. So remember, quotient, we're not turning around. We're going to write them in order because the order matters. So the quotient of a number and 4 is 7. So of some number divided by 4 is 7 is what this is saying. All right, now how do we get this x alone? Remember, opposite operations, that's what we did up here. We were multiplying, so we divided. We were subtracting, so we added. We're dividing now. What is the opposite of dividing? Multiplication. So what we want to do to get rid of this denominator is we want to multiply both sides of this equation by 4. And remember when we did dimensional analysis, when you have the same term up and down and you're multiplying, they cancel out to 1. Okay, that leaves just x on the left, and 7 times 4 is 28. All right, let's see. Let's take a look at number 4. The product, remember product means multiplication, of 3 and a number increased by 4 is 42. So the product of 3 and a number, I don't know what the number is. I'm going to use x for it. So the product of 3 and a number, I'm going to say 3x increased by 4 plus 4 is 42. Okay, so we're getting a little more complicated here. Now, we've had where we were multiplying, so we divided to get rid of things. We had where we were subtracting, so we had to add to get rid of the terms to get them to the other side. We have two things going on. The rules say we need to isolate where the variable is before you can do anything else to it. Where the variable is located needs to be the only term for us to get it along. I have 2 terms on this side, so I need to move the 4 in order for me to be able to isolate the x. So I need to have only 1 term on the side where the variable is in order to isolate it. So I'm going to do the opposite operation. This is plus 4. I'm going to say minus 4. Minus 4, because it's an equation, so you have to do the same thing on both sides in order to keep it equal. These 4's cancel out to 0 because 4 minus 4 is 0. We bring down the 3x because nothing's changed with it, equals 42 minus 4 is going to be 38. Okay, now we want to get the x alone. This is 3 times x, so we're going to divide by 3 to get that 3 to cancel to a 1. We have to divide by 3 on the other side. This is not going to be a pretty number, so I'm just going to leave it as 38 divided by 3. Depending on what the question was, we could have gone ahead and put it into a decimal form, but leaving it as a fraction is fine too. Okay, let's try a couple more here. We have 3 times the sum of 4 and a number is 42. Okay, 3 times, so we know we've got some multiplication of there. But the sum of, that is telling you that's a parenthesis phrase. Okay, remember from our notes previously. So 3 times the sum of, and we're going to be adding, 4 and a number is 42. Okay, so the sum of 4 of a number, so we can say x plus 4. That's the sum of 4 of a number, but I need to 3 times that. There's your parenthesis, so the 3 goes in front here. We're saying 3 times the sum of 4 and a number is 42. Now there's a couple ways to solve this one, as with most algebraic equations. I'm going to do the way that I think most of you will think of when you see this, because you're going to see the 3 next to a parenthesis and you're going to say, I want you to distribute. So I'm going to go ahead and distribute. 3 times x is going to give you 3x. 3 times 4 is a positive 12 equals 42. Okay, now this problem is very much like this problem that we just did. You need to get the variable by itself. It needs to be the only term on that side of the equation for us to be able to solve for it. Since I have 2 terms over here right now, what I want to do is I want to move this 12. I want to subtract 12 to move it away from the 3x, so I'm isolating it. This is a positive 12, so we're going to do the opposite. Minus 12, minus 12. Okay, 12 minus 12 cancels to 0. It's gone on the left, but it got put to the right. So we're left with 3x equals 42 minus 12 is 30. This is 3 times x, so we're going to divide by 3 on each side, and I get x equals 10. Okay, so hopefully we're remembering some of our solving here. All right, last one on the front. We have 6 less then the product of 3 and x is 65. Okay, so is 65. So we know it's going to equal 65. 3 less than. Less than is one of those turnaround phrases, so we do not want to leave this as 3 and x, as 6. So we have 6 less than, meaning subtract, the product of 3 and x. We don't want to write it in this order because less than is your turnaround phrase. Okay, so we're really saying 3x minus 6 is 65. Now let's go back and read it. 6 less than the product of 3 and a number. So this is saying the product of 3 and a number minus 6. So that'd be 6 less than that. Okay, is 65. Now, this is another two-step equation. These previous equations that we did were 2 steps because we had to do 2 things to our equations in order to get our variable alone. See how there's 2 terms on this side. So we needed to get down to just the term with the variable in order to get the variable by itself. So we're going to move this 6 first. So this is minus 6. The opposite of minus 6 is plus 6. So we're going to add that to both sides of the equations to keep it equal. Negative 6 plus 6 is 0. Cancels out. I'm left with 3x on the left equals 65 plus 6 is 71. Now to get the variable alone, this is 3 times x, so the opposite of multiplication is division. We will divide both sides. And I'm going to have x equals, and I'm going to leave it as a fraction because it's not going to be pretty, 71 divided by 3. All right, let's flip this over and do a couple of real-world examples on the other side. All right, here's some real-world examples. So in number 1, you are buying a new printer and a new scanner. So we're buying a printer and a scanner for our computer, and we cannot spend more than $150. Okay, so it needs to equal $150. That's the most we can spend. The printer we want is $80. What is the most that we can spend on the scanner? So we have $80 for our printer plus some amount that we don't know what it is. So I'm just going to use X because we're really good at using X. And we can't have it be more than this. So it has to equal $150. Okay, so you probably could have done this in your head. When you go shopping, a lot of you can figure out, if I have this much money and I want to buy this that costs this much, how much more do I have left to spend? That's an algebraic problem. Okay, so we want to isolate the variable, which is our x. See how we have 2 terms on this side, so we need to move the term that doesn't have the variable in it first. That's a positive 80, so I'm going to subtract 80. These guys cancel to 0, leaving just the x on this side, and 150 minus 80 equals 70. So we can spend $70 on our scanner. Almost as much as the printer. Okay, how about this example? We are making a beaded bracelet for our friends. We want to use 30 beads for each bracelet, and we have a total of 240 beads in all. How many bracelets can we make? Okay, so if I want to use 30 beads for each bracelet, so I know each bracelet is 30 beads, and I have 240 beads. There's no variable in here right now. The variable comes in is how many bracelets can I make? So 30 beads times the number of the bracelets. Okay, so 30 beads times the number of bracelets equals 240 beads. So to solve for that, this is just one term, so I don't have to add or subtract anything to move it away. This is 30 times x. We're going to divide both sides by 30. And x equals 240 divided by 30 is 8, which means we can make 8 bracelets. Okay, now these have been one-step equations. We only had to do one operation in order to find our final answer. They're not always that easy, but sometimes they are. So let's look at number 4. We'll skip number 3 because number 3 and 4 are almost the same problem. Your school is building a new computer center. 400 square feet of center will be available for computer stations. Each station requires 20 square feet. How many computer stations can be placed in the new center? So this is what we're wondering. That's going to be our variable. How many computers?